For this section, we're going to be continuing on with synthetic division. So this process may look intimidating at first, but you'll find that it's actually a relatively quick and simple process compared to the long division that we have worked with. So, for synthetic division, we say given a polynomial with degree n, so the largest exponent is n, and a divisor of x minus c. So it needs to be in the form x plus or minus some number for this to work. We say that the first thing that you have to do is order the dividend by exponent. So you need to make sure that your terms are something like x cubed plus x squared plus x plus 1, for example. And then from there, we need to make sure that if any gap in the exponent exists, we fill it in with a plus 0x to that power. So for instance, if the problem goes from x cubed plus x, we're missing an x squared, we need to fill in a plus 0x squared. It seems odd, but it will actually throw off the process if we are missing those values. We need every single exponent. At that point, we're going to remove everything but the numbers and their signs. So we're going to remove all the x values, all the exponents. All we care about are the coefficients in front of them. We can then set x minus c, the divisor, equal to 0, and then solve for x. So we'll say x equals c, and when we do this, we'll put c on the left of the set of numbers that we found in step 4 when we removed all of the x's. At this point, it's going to be somewhat similar to long division. We're going to bring down the first number, multiply it by that number off to the left, the c value, and then add that to the second number, and that result will be brought down, and then we'll just keep repeating these steps over and over and over until we run out of numbers to keep adding. And at this point, we now have our answer. It seems a little bit odd. The only thing you'll notice is that we have a bunch of random numbers, but these numbers represent the coefficients of our polynomial, with the degree now being 1 less than it was before. So it's n minus 1, and the last number will be the remainder. So if the last number is 0, the remainder is 0, otherwise you have to account for what it is. Okay, so like I said, this is a very long and intimidating process, but once you see the actual process at work, it will make more sense. So let's go ahead and try this. The first thing we have to do is make sure that our dividend is ordered by exponent. It is. We have x cubed plus 6x plus 8, 5x cubed that is, plus 6x plus 8. But notice we are missing the x squared term. So we need to fill that in. We have 5x cubed plus 0x squared plus 6x plus 8. And now that we've filled in that 0x squared, we can apply step 4, where we'll remove everything but the numbers and their signs. So we have a 5, a 0, a 6, and an 8. Notice we've removed all the addition symbols and the x's. All we care about is the numbers and if they are negative. So we now have 5, 0, 6, and 8. We now need to solve x plus 2 equals 0 off to the side. So we'll subtract 2 from each side to get x equals negative 2. And that negative 2 will go off to the left of these set of numbers. And now we always do the same thing. We're going to bring down the first number, which is 5, and multiply it by the number on the outside. 5 times negative 2 is negative 10. And add that to the second number. 0 plus negative 10 is negative 10. Times negative 2 is positive 20. 6 plus 20 is 26. Times negative 2 is negative 52. Plus 8 is negative 44. These numbers represent the coefficients of our answer, and we always start with an exponent that's one less than the largest one we started with. Why is that the case? We're dividing x cubed by x, so the result should be x squared, or one less than we started with. So we get 5x squared minus 10x plus 26, and now this minus 44, the last number, as I said, always represents the remainder, so we get minus 44 over the original divisor, x plus 2. And this is our solution. 5x cubed plus 6x plus 8 divided by x plus 2 is 5x squared minus 10x plus 26 minus 44 over x plus 2. Okay, so from here, I want you to take a moment, see if you can't try the same thing with 2x to the fourth minus 5x cubed minus 20x squared plus 35x minus 12 over x minus 4. It seems like a very intimidating problem, but just try to follow the same pattern we used in the last example. Pause the video and then we'll try it together. Okay, so first thing we should check for is, are the exponents ordered, which they are, and are there any missing exponents, which there are not. So we just have 2x to the fourth minus 5x cubed minus 20x squared plus 35x minus 12 in the exact order it's given. We can immediately remove the x's. So we get 2, negative 5, negative 20, 35, and negative 12. We now want to take our divisor, x minus 4, and set it equal to 0 and solve for x. So we'll add 4 to each side, which gives us x equals 4. And that's going to be our value off to the left. We always want to put this little box symbol here to signify that it is separate from the other numbers. And now remember, we want to bring down the first number, 2, and multiply that by our 4, which gives us 8. Negative 5 plus 8 gives us 3. 4 times 3 gives us 12. Negative 20 plus 12 gives us negative 8. Negative 8 times 4 gives us negative 32. Plus 35 gives us 3. 4 times 3 gives us 12. And negative 12 plus 12 gives us 0. Remember, the last number represents the remainder. Since we have a remainder of 0, it divided in evenly. So these represent the coefficients of our answer, and we always start with one less than the largest exponent we had. So x to the fourth means this is going to start with x cubed. So we have 2x cubed plus 3x squared minus 8x plus 3. This is the result of the original problem being divided by x minus 4.